Welcome back. Welcome to this learning path 04, which is titled Java Cloud Quick Start. A number of times I am asked a question: how can I become a full stack developer? How can I become an API developer? How can I become a cloud developer? How can I become a microservices developer? These learning paths are an answer to that question. After watching these learning paths, you'll be very clear on how to reach your specific goals. The goal of this specific learning path is to help you get quickly started with the cloud with the Java applications and use AWS, Azure and PCF. Each of the learning path will contain the details of the frameworks, tools that you would want to learn, as well as the details of each one of these. So it will contain details on what in specific you should learn about AWS Elastic Beanstalk, what in specific should you learn about PCF, and also it would contain course recommendations, it will contain video recommendations of what you can learn to reach the final objective. Now, the prerequisite for this specific learning path is that you should have completed learning path 01, which was actually to build a REST API or a web application with Spring Boot, or you should have completed learning path 02, which is to build a full stack application with Spring Boot. If you have completed either of those learning paths, then you are ready to start this learning path. However, if you have not started those learning paths, I would recommend you to check those learning paths out and build at least a single web application or a REST API or a full stack application before you would pursue this learning path. So the prerequisites are Spring Boot, JPA Hibernate, and you should have developed either a web application, full stack application or a API. And let's now deep dive into all this stuff in the cloud that you can do with your Java Spring Boot applications. Let's get started. Now, let's shift our attention to one of the most important topics of the recent years, cloud. Why should you learn the cloud? That's the number one question. And what should you learn about the cloud? So let's get started with the first question. Why learn cloud? The number one reason why you should learn the cloud is because of something called on-demand resource provisioning. What is on-demand resource provisioning? In the cloud, you can get resources whenever you want to ask them for. If you look at the world before the cloud, you have to start planning infrastructure months ahead. So if I expect a huge amount of load, I would need to start planning the infrastructure well in advance. However, with the cloud, you don't really need to do that. You can ask for a resource when you need it and you can release it when you don't need it. What are the advantages of that? Let's say you are Amazon. You'll have peak period of load during any of these shopping seasons. Let's say Black Friday. Let's say a New Year's sale or something of that kind. For rest of the time, you will not have as much load. What would the infrastructure be doing when there is no load? It would be sitting idle. That's what you can avoid by going to the cloud. Let's say you are a startup. You don't know how successful you will be. So you can start with a little bit of resources in the cloud, and as you grow, you can increase the number of resources that you provision. So on-demand resource provisioning is one of the most important reasons why cloud is becoming very popular. Now, what are the other reasons? The other reasons are avoid undifferentiated. So this is a little tricky. Undifferentiated heavy lifting. What is undifferentiated heavy lifting, right? So let's say you are an insurance business. What would differentiate you from your competitors? It's about giving good insurance products. Let's say you are a shopping platform, or let's say you are a bank. What really separates you from your competitors is not the technology platform, it's not how you do service discovery, it's not how you build your containers, it's how you service your customers. So that's the important thing for a business to focus on. How to do containerization, how to do service registry, all that stuff is actually part of something called undifferentiated heavy lifting. It's a lot of hard work that you do without a huge amount of differentiation from your competitors. And businesses should avoid undifferentiated heavy lifting. Cloud provides a number of services like managed databases, like platform as a service offerings, where you don't really need to worry about how the platform is working. All that you need to do is build an application, deploy to the platform, and the platform would make sure that the availability concerns, the backup concerns, the redundancy concerns, all of them are taken care of. So, number two reason why people go to the cloud is to avoid undifferentiated heavy lifting. You don't need to do the stuff which does not give you any differentiation. The third reason why people go to the cloud is improved latency and availability. So, what is improved latency and availability? With the cloud, you get a feature which is called availability zones and regions. So, if let's say this is the world map and you have a number of continents everywhere, I'm not really good at drawing maps, so that's something you have to forgive me for. With each of these cloud providers, whether we are talking about AWS or GCP or let's say Azure, each of these cloud providers have regions across the world. So they have regions in all the important continents across the world. So they have data centers present in different corners of the world, and even within these regions you have things called zones or availability zones where you have multiple instances present. What this helps us to do is, if you are a startup, you don't really need to have all your data center at one place. What would happen if I have data center at one place? If a request comes from a customer in somewhere other corner of the world, then the request for him will be slow. So there will be latency for that specific user. And you can avoid that by going for the cloud. You can deploy your application in multiple regions with a single click of the button, and therefore your users will get the best latency, best performance possible. You can also improve the availability of your application. So inside the same region, you can deploy it into multiple availability zones, so that even if one of the places the application goes down, it can be served from other places. So that's the reason why cloud is really getting popular in these days. So now you have decided you want to move to the cloud. You are satisfied with all the reasons. The first decision that you need to make is, how do you move to the cloud? And there are a number of options on how you can actually move to the cloud. The first option is something called lift and shift. Let's talk about it a little later. For now, let's list down all the options. The other option, the second option, is to actually use a cloud specific application platform as a service. So this lift and shift is called IaaS, where it's called infrastructure as a service. The cloud specific app, PaaS, is platform as a service. The other options are cloud specific, container orchestration. So container orchestration. The fourth option is actually cloud neutral. So instead of specific, this is neutral. So cloud neutral container orchestration, typically using Kubernetes. The last option is also very interesting. You have an intermediate platform. Instead of going to the cloud directly, you can go through an intermediate platform called PCF or OpenShift, things like that. So these are all the options that you have to go to the cloud. So let's start with actually discussing what is IaaS versus PaaS, infrastructure as a service versus platform as a service. Typically, whenever we talk about applications, where do they run? They run on hardware, right? So you have networking. So you have networking, you have hardware. On top of the hardware, there is also storage and other stuff which can be present, hard disk and other stuff. On top of it, if we are in the cloud, we would need to have some kind of virtualization so that we can use the hardware in the cloud. On top of it, you would want to install the operating system. On top of it is where you would have your runtime. So the runtime can be application runtime, container runtime, or whatever it can be. And on top of it is where our apps run. So finally your apps, your data, everything is at this particular layer, right? So this is how things are in the cloud. So you have your network connectivity, on top of it is your hardware, you have virtualization layer, you can install whatever operating system you'd want, you can actually choose any runtime, maybe you'd want to install Java, you'd want to install Tomcat, all that are runtimes, and on top of it is your apps. So that's the whole thing. Now, from the cloud, you can ask for just the servers. So you can actually ask, hey, I would want a Windows operating system and I would want one virtual server. That's called a infrastructure as a service. So you are asking a server, you are asking a specific service with a specific operating system. Typically, all these cloud providers provide infrastructure as a service as well. So in Google Cloud, these virtual servers, so whatever virtual servers we are talking about in here, let's just say virtual servers. In Google Cloud, it's called as compute engines. In Microsoft Azure, it is called as virtual machines, Azure virtual machines. In AWS, these virtual servers are called as EC2, Elastic Compute Cloud. So the names are different, but the concept is same. You can say, I would want a virtual server with this configuration and this operating system. And then you can take that and you can install whatever runtime you would want. You can install Java, you can install Tomcat, you can install whatever you'd want, and you can install your apps and databases on top of it. So this is what is called infrastructure as a service. You can go for this. So you can take your application which is present outside, right now in your data center. You can take it, you can ask servers in the cloud and you can deploy it as it is. So let's say you have an application which is running inside your data center. Let's say it's like Tomcat based, running on Unix. You can ask for a Unix server and then you can install Java and you can install apps on top of it. So you are taking complete responsibility for this specific part. So the platform provides all this stuff and you are responsible for runtime and the apps. The other service which the cloud platforms also provide is something called a platform as a service. It takes it to the next level. This is called a platform as a service, where they provide the runtime and they provide a number of additional features as well. They take care of availability, they take care of taking backups, redundancy, and all that stuff the cloud platforms can take care of. Let's look at a couple of examples of PaaS. So let's start with, let's say I would want to deploy an application. What are the platform as service offerings that are present that can help me to deploy a Spring Boot application to the cloud? Let's talk about AWS. With AWS, the platform as a service offering is called Elastic Beanstalk. AWS Elastic Beanstalk. The awesome thing about Elastic Beanstalk is you can give it a var file or a jar file and that's it. It would take care of managing it. If you want multiple instances, it can create it. If you want load balancing, if you want auto scaling, all that stuff are built in. So you are only worried about the apps. The rest of the stuff, the platform, AWS would take care of it. Similar services are also provided by other cloud platforms. Azure provides a service called App Service or Web Apps. So Azure Web Apps is an amazing service. Again, all that you need to do is give it a jar, a var, a container, any of these things. All these services work with all that stuff. So it would be able to manage the whole thing. So the Azure Web Apps is a platform as a service. And Google also provides something very, very similar. It's called Compute Engine. So Google Compute Engine will help you to manage an application. So you give it a jar or a var or a container and it would take care of rest of the things for you. Now that's one way, deploying applications. The other way you can make use of PaaS, platform as a service, is by using something like databases. So you can use the database services which are provided by the cloud. In AWS, you have relational database service. In MySQL, you have a MS SQL database service. Similar services exist in Google as well. So instead of managing the database on your own, taking backups, managing the availability, making sure that the redundancy is present. By redundancy, I mean instead of having the database present in one availability zone, one place, you can have it present in 2 or 3 availability zones which in the same region, so that even if one of the availability zone goes down, the data from the other availability zones is present for you. So all this stuff are automatically provided by the platform for you. All that you need to worry about in the case of databases is the data. You don't need to worry about how to install a database and all that stuff. All that stuff would be taken care of by the platform provider. So the first option we looked at was infrastructure as a service, where the cloud provider would provide you just the infrastructure and you do the lifting and shifting. You take care of installing the applications, installing the runtime and all that stuff. The second option we looked at was platform as a service, the basic platform as a service offerings, right? So databases, in the case of like each of the clouds, there are basic platform as service application offerings. The other option you have is, let's say you are having microservices. In those kind of situations, you'd want to go for container orchestration. If you have multiple microservices and they talk to each other, you'd want to manage them using something called a container orchestration tool. So you can go for a cloud specific container orchestration tool. In AWS, there is something called ECS or AWS Fargate. So AWS ECS, you have to manage the clusters. AWS would take care of actually providing, with AWS ECS, you are responsible for providing the container images, configuration, and you are responsible for managing the clusters. With Fargate, you are no longer responsible for managing the clusters. You are just responsible for managing the applications, the container images, and the configuration. Fargate would automate everything. Fargate is also called serverless for containers. So that's the option number 3. So this is option number 2, 1. And the fourth option is actually to use a cloud neutral container orchestration. The problem with the cloud specific container orchestration is if you are using AWS Fargate or AWS ECS, then you are tied to that specific cloud provider. You can go for cloud neutral container orchestration by using Kubernetes. So you can create containers, you can create containers for your microservices and or get them orchestrated by Kubernetes, and each of these cloud providers provide Kubernetes services. Google provides GKE, Google Kubernetes Engine, Azure provides Azure Kubernetes Service, AWS provides Elastic Container Service for Kubernetes, EKS. So all these are like the Kubernetes offerings from various cloud providers, and once you use Kubernetes, the advantage that you have is even though you are running on the cloud, you can shift from one cloud to another without a big problem. The other option is to use an intermediate platform. Option number 5 is to use an intermediate platform like PCF. If you are a Java shop, if you are using Spring Boot, if you are using Spring Cloud, then PCF might be a very interesting option. So what PCF does is it sits in between your apps. So you have PCF in here, you have your apps in here, and below this is your cloud. So it might be AWS or it might be Azure or it might be Google Cloud. So you can deploy your apps to PCF and PCF would take care of deploying it to the right cloud. So you can configure how you'd want to do it and all that stuff. So with PCF, it provides a lot of interesting features which makes it very, very interesting, especially if you are a Java shop. If you are doing a lot of Java things, then PCF is a very, very interesting thing. The idea behind giving an overview of the cloud is to show all the various things that you can learn about the cloud. As far as this learning path is concerned, we'll probably focus on just a few elements of this cloud learning path. We might not want to learn everything because that would be tough. So we would focus on specific things as part of this learning path. Now, we talked about a number of platform as a service offerings. We talked about Elastic Beanstalk. We talked about App Engine. We talked about Azure Web Apps. And we also talked about PCF. If you look at all these platform as a service offerings, they offer a few common features. One is you can have any number of applications deployed. The other is they all support multiple environments. So you can have a dev environment, a QA environment, stage environment, and all that stuff for all the applications. They have different names for each one of these, but basically they support multiple environments. You have support for multiple platforms and also multiple languages. So you can deploy a Java application, a Python application, and all that stuff. You can deploy a jar file, a var file. You will also have support for container and a multi-container application. So you can build an Docker image. You can use that to deploy an application down to the platform as a service provider, and you can also use a multi-container. So if you are aware of what Docker Compose is, you can run multiple containers at the same time. So you can use that stuff also to run your applications. So most of the cloud provider platform as a service offerings, Elastic Beanstalk, provide support for multi-containers as well. These platform as a service offerings also allow different deployment strategies. When you want to release a new application out to production, you don't want downtime at all. You want one service, while the service is live, you'd want to be able to test the new version of the service and take the old and replace the old version with the new version. This is called blue-green deployment, and almost all the platform services, platform as a service offerings, the basic ones, support this. The other options that are provided are auto scaling. You can scale the number of instances based on the demand. You have load balancing present. So you can load balance between multiple instances automatically, and they also provide a continuous integration and continuous deployment options. In the case of AWS, you can do actually it's AWS Elastic Beanstalk. So this is AWS Elastic Beanstalk. This is Azure, actually this is Google App Engine. This is Azure Web Apps. Oops, it's a little confusing now. So in the case of AWS, you can use AWS code pipeline and code build to do the continuous integration and continuous deployment. In the case of Google App Engine, you can use Google Cloud Build. In the case of Azure Web Apps, you can use Azure DevOps to do the continuous integration and continuous deployment. So all that you need to do is you have your code in a Git repository. So once you commit the code out, so from your local machine, you commit the code out to the Git repository. You can have a build scheduled using any of the tools that we have talked about right now, and it would directly deploy it to the appropriate platform. So this is the advantage of continuous integration and continuous deployment. You can continuously keep deploying new versions of the code, and if you have automated tests and all that stuff, that's amazing as well. Now, one of the important questions you might be wondering is how to identify which one to choose, right? It's a very, very difficult question because most of the basic features are provided by almost all the basic platform as a service offerings by all the cloud providers. So let's look at a few of the differentiators. One of the interesting things about Azure Web Apps is that it provides a concept called app service plans. So Azure Web Apps provides a number of app service plans like F1, B1, B3, P1, V1, and a lot of other stuff. These app service plans define what are the capabilities and what are the capacities. What I mean by capabilities is things like, is auto scaling supported? Can there be multiple slots? Can I have multiple environments? Are backups automatically taken? And by capacities, I mean how much CPU, how much memory. So in Azure Web Apps, before I would be able to deploy an application, I would need to create something called an app service plan, defining what are the capabilities I need and what is the capacity I would need. And the interesting thing is the billing starts as soon as I create an app service plan. So even though there are no apps, the billing starts immediately. So that's one interesting thing about Azure Web Apps. The other interesting thing that might be useful in Azure Web Apps is resource groups. So you can actually group a lot of resources belonging to single application into a single resource group, and it really helps you to manage things very, very easy. And one interesting thing about Azure Web Apps is it has support directly for Docker Compose. So earlier we talked about multi-container support. You can directly take your Docker Compose file and run it directly in Azure Web Apps. However, like in things like Elastic Beanstalk, you had to actually adhere to a AWS specific configuration file. You cannot use Docker Compose file for multi-containers. You have to actually change it a little bit to adhere to a AWS specific multi-container file. The other interesting thing about AWS is the S3. So there is something called S3, which is object storage. So S3 is an object storage in AWS. The interesting thing is S3 is highly available. I mean, we were talking about multiple regions, multiple availability zones and all that stuff. With S3, anything you have in S3 is like really one of the most available things that can be present in our planet. So if you deploy and the interesting thing is actually you can deploy a front-end application to S3. So anything that you would want to actually run in a browser, you can actually deploy it to S3. So JavaScript, HTML and all that kind of stuff you can deploy to S3 and make use of all the features that S3 provides, like availability, latency, like low latency and all that stuff. So S3 is one of the big differentiators with Elastic and going for AWS, because you can actually deploy a front end to S3 and it would take care of all the service requirements that you have. The other interesting thing is the fact that Google App Engine is actually one of the oldest. I don't know if it's really an advantage, but it's really one of the oldest. I think Google App Engine goes as far as 2008. Now, one key differentiator for PCF is it has amazing support for Java, Spring Boot and Spring Cloud. Also, the other important thing is it supports all the microservice infrastructure needs as well. Let's say you'd want to deploy a microservice to PCF. You typically need things like service registry, config server, histories. All these Spring Cloud services are offered as managed services on PCF. So it makes it very easy to deploy your Java, Spring Boot, Spring Cloud microservices out to PCF. So those are some of the important differentiators between all these platform as a service offerings. The best way to learn all these platform as a service offerings is to deploy multiple applications, deploy a jar file, deploy a WAR file, deploy a REST API, deploy a web application, deploy a full stack application and play around with it. Now let's shift our attention now on how to learn AWS Elastic Beanstalk. What are the things you can do to learn Elastic Beanstalk in depth? One of the key things that we would recommend for any platform as a service offering is to deploy multiple applications. So you can actually deploy a jar file, a WAR file, you can deploy a REST API, you can deploy a web application, you can deploy a full stack application and try Elastic Beanstalk. So that's number one thing that you can do to learn Elastic Beanstalk. The second thing that you would want to do when you would play with Elastic Beanstalk is to try all the services which are present inside AWS. So you'd want to be able to create a database and connect your Elastic Beanstalk environment to it. So you'd want to maybe use the RDS service. You'd want to play around with continuous integration and continuous delivery with AWS Code Pipeline and AWS Code Build. You might want to try different monitoring features that are available like Cloud Watch. So these are all the interesting features that you might want to learn when you are playing with Elastic Beanstalk. Now let's move on to Azure Web Apps. What are the things that you can learn when you are playing with Azure Web Apps? The first thing you can try to do when you are playing with Azure Web Apps is to deploy a number of applications, deploy a WAR file, deploy a jar file, deploy a full stack app, deploy a REST API, deploy a web application, deploy a container. So you can also deploy a multi-container. So try and deploy all the variety of things and see how they are present in web apps. You can also create a managed service for MySQL. So you can create a database in the cloud and connect your applications to it. You can also play with a number of app service plans, and you can also learn the basic concepts around the resource groups, app service plans, Azure subscriptions and all that fun stuff. You can also try doing CI/CD, continuous integration, continuous delivery with Azure DevOps. So those are some of the interesting things that you might want to play with when you are talking about Azure Web Apps. Now let's look at what are the important things that you would want to learn about PCF. The interesting thing about PCF is the code around it. When you go to any of the PCF websites, this is the code which would be present. Here is my source code. So it's here is my source code, run it in the cloud for me. So that's the code for PCF. I don't care how. So if you look at PCF, as we discussed earlier, PCF sits between your cloud provider. So it can be AWS, or it can be Azure, or it can be GCP. Any of these cloud providers, you can actually deploy your applications to by using PCF. So it sits between your apps and your cloud provider. It makes it easy for you to go to the cloud, especially if you are in the Java microservices world. So this is the code which I found really interesting. And the great thing about PCF, as we talked earlier, is the fact that PCF supports both simple applications like web applications, full stack applications, containers, and it supports microservices. This is one of the unique things about PCF. It's one of the basic platform as a service offerings which supports microservices really well. It supports integration with Spring Cloud services like service registry. It supports config server. It supports Hystrix. So all the typical microservice features it would support by default. It would provide all the typical platform as a service featurings like high availability, redundancy, like scaling, auto scaling, load balancing, blue-green deployments. All these kind of stuff are automatically provided by PCF for you. Some of the important concepts that you need to understand when you are playing with PCF are concepts called build pack. You have a concept called a droplet. So these are a couple of important things that you need to understand. So when you have any piece of code, what you need to do is you want to deploy it. And to deploy it, what you need to do is you need to create something called a droplet. And there are a number of build packs that are provided by Cloud Foundry which help you to take your code. So you give a code to a build pack and the build pack would give you a droplet. And this droplet is ready to be deployed onto any of the PCF environments. This is a concept that you need to really understand well when you would actually play with PCF. There you go. Those are some of the important things that you would want to learn about PCF. The most important thing I would think is to play around with a variety of applications. Now that we looked at all the skills in depth, let's look at the different recommended videos and recommended courses for this specific learning path. The link, you will find it in the description. This is Learning Path 04. You will find it in the description of the video. And the recommended skills, as we discussed earlier, are to know how to build at least a web application, a REST API, or a full stack application. Once you know that, that's basically the prerequisite, Learning Path 01 and Learning Path 02. Once you know that, you can actually go in and use any of the cloud provider options to deploy your services, to deploy your applications to the platform as a service offering. So the recommended learning path is to learn AWS. I mean, take your Java web applications and deploy them to AWS Elastic Beanstalk. This course helps you to learn basics of AWS, basics of AWS Elastic Beanstalk. It helps you to deploy a variety of applications. You can deploy a REST API, a web application, a full stack application. You'll deploy a container, a multi-container, and you'll do all the features that are typically present on a platform as a service offering. Continuous integration, continuous delivery, auto scaling, all that stuff you'll be doing as part of these three courses with all these three different tools. So over here, Elastic Beanstalk course does it with AWS Elastic Beanstalk. The Azure Web Apps course does it with Azure Web Apps, and the PCF course does it with Pivotal Cloud Foundry. So all these three courses are similar in the sense that they take a number of Spring Boot applications live to different cloud platforms. And I think this is an amazing way to get quick exposure to clouds, different cloud platforms, to look at what offerings they have, to get a high level understanding of everything related to your cloud. We also offer a few preview courses, so you can look at Learn Docker in 5 steps and also a few 10-step tutorials on Elastic Beanstalk, Pivotal Cloud Foundry, and Azure Web Apps. Learning cloud is very important. I cannot stress the importance of learning the cloud as a Java developer, especially becoming a multi-cloud developer is very important. As enterprises start moving to multi-cloud, it's very important that you have the skills to understand different cloud environments and learn to deploy applications there. I'm sure you are having a wonderful time, and I'll see you in another video very soon. I'm sure you had a wonderful time watching this video. A number of times I am asked this question: where do I go from here? What next? There are 4 amazing things that you can do to benefit from the great content that we are creating at in 28 minutes. A number of developers wonder how they can become a full stack developer, a cloud developer, a microservices developer, or a DevOps developer. We have amazing learning path videos to help you understand all these career paths and decide what you want to be. Number 2, this video is part of a series of video called Draw with Ranga, and you can actually download the free PDF containing all the amazing images which we have drawn during these series of videos by registering for a free course. Number 3, you can check out our 500 plus amazing videos that we have created over a period of last few years. These videos are organized into playlists to help you learn Spring, Spring Boot, full stack, microservices and the cloud. Last but not the least is number 4, check out our course catalog. We have a wide range of courses to help you become an amazing developer. So what's stopping you? Go ahead and keep learning in 28 minutes. If you like this video, make sure that you like and also subscribe to this channel. Until I see you in another in 28 minutes video, here's bye from Ranga at in 28 minutes.